All right, so we're going to start out by looking at section 7.5, okay, which is on the sum and difference identities. Okay, so I'm going to start just by looking at what's on the left and what's on the right. Okay. Anybody have any thoughts about how those two things would compare? What do you think would happen if you graph, well, what's one thing that could happen if you graph one on the left in y1 and the one on the right in y2? They could be, Dave, what do you think?
Are they the same?
Okay, they might be the same, or they could be
Different.
different. Well, it's one of those two. Let's look at the sine function. Look at it from a transformation kind of point of view. What happens when you add a number inside the parentheses? Which way? How does that affect the graph of sine x? Remember what that plus 3 would do? It would do the opposite, but which way would it?
So it would shift it left.
Yeah, this would shift it left 3 units. So just think of it that way. This is a shift left 3. Now, this one, you're on the right, you're taking the sine of x and you're adding something onto the end of it. Right? Sine of 3, it comes out to some number. What happens if you add something at the end of a function? What does that do? Shifts it up. So just thinking about it from transformation perspective, these are not the same. That's a vertical shift on the right. That's a horizontal shift on the left. Okay? So the idea is you cannot do the distributive property with the word sine. Okay, that doesn't work. Okay, the only thing you can distribute is if you have a letter on the outside or you have a number, you can use distributive, but you can't do it with the sine function. Okay, so we're going to look at what does work. Specifically, this is called the sine of a sum. That's what's on the left here, the sine of a sum. We're going to look at 4 formulas. Sine of a sum and a difference, and then cosine of a sum and a difference. I'm not going to start out with the one for sine. I think I'm going to start out with cosine. Okay, and I'm going to do the cosine difference. There's a proof of this formula in the book. It's a little bit lengthy to go through. It's not the easiest proof. I've done it in the past, but it's really, for the amount of time it takes, it's not worth really doing it. So if you go through it, that's the formula that you'll get. And this formula you can use, bless you, to figure out all the other formulas. We can use that to figure out cosine of a sum, bless you, sine of a difference, and sine of a sum. Okay, so we're going to use this as kind of our starting point to figure out everything else. All right, so alpha and beta would be two angles. And if you want to do the cosine of a difference, the formula is cosine of the first times cosine of the second plus sine of the first, sine of the second. Okay, it's not too hard to remember that formula when it's by itself, but once you learn the cosine sum and the sine of a sum and the sine of a difference, they're all kind of similar, so it's hard to keep track. You know, is it a plus in the middle or is it a minus? There's little changes in all of them. Okay, and the proof of that is on page 409. Okay, I'm not going to go through the proof, but if you were to look at it, it has something to do with these diagrams, and it involves making a couple different triangles and then measuring some angles. But again, it is a little complicated to go through. Any questions on the formula? Now, the two angles, the one you have here and the one you have there, you want them to be easy to work with. Okay, so what kind of angles are easy for us to work with? Angles that are multiples of what number? I think when we did unit circle trig.
45.
Yeah, any angle that's a multiple of 45, that's a good one to use. And angles that are also multiples of 30. Okay? If you pick angles that are multiples of 30 and 45, it makes it so you can do it. You cannot let alpha or beta be something that's not a multiple of what we just said. Okay, so for example, you can't plug in 10 for alpha. You won't be able to do it. Okay, it's got to be multiples of 30 or 45. All right, so using that idea, I want to find the exact value of the cosine of 15. So when we did unit circle trig, probably back in chapter 6, we found the exact values of anything that was a multiple of 30 or 45. Well, now I'm also saying we can do the multiples of 15. And that really covers everything that's a multiple of 30 or 45. Okay, think about if you list all your multiples of 15, that's automatically going to include everything that's a multiple of 30 and 45. Okay, so that's kind of a shorter way to say what we can really do, multiples of 15. Right. First thing I have to do is rewrite this somehow. And I want to rewrite it using what we just looked at on the previous page. So can anybody tell me how you can rewrite 15? And we're going to write it as a difference. But it has to be using numbers that I mentioned earlier.
It's 45 minus 30.
Yeah, you can do it as 45 minus 30. Okay. Any questions on that? So that's an easy one to figure out. Sometimes it's a little harder to figure it out, but there is a way. If I give you a problem, there will always be a way to write it in terms of 45s and 30s somehow, or multiples. So now we're going to use that formula. We're just going to plug in what we did for alpha. Okay, that's what we put right here. And then what we plugged in for beta. Okay, so it's cosine of the first, cosine of the second, cosine of the first, cosine of the second. And the only thing that's a little tricky is when it's a cosine, the difference, when you rewrite it, turns into a sum. Okay, so you just have to remember plus sine of the first, sine of the second. Now, all of these, we have to know them, okay, because they're all multiples of 45 and 30. So they're going to be things like 1/2, square root 2 over 2, square root 3 over 2. We just have to know what they are. If you don't know what they are, you can type it in. You'll get a decimal, but then you have to recognize the decimal, okay, as one of the numbers I just said, like 1/2, square root 2 over 2, square root 3 over 2, things like that. All right, so let's look. Does anybody remember what the cosine of 45 is? All right, so then if we type it in and we get it as a decimal, we have to recognize it as an exact answer, okay? Because the problem said exact, so we can't round anything off. All right, so the cosine of 45 is 0.707. What's 0.707 as an exact fraction? Alan, do you remember?
Is it power 4?
No, there's no pi in any of them.
Oh, okay.
Yeah, no pies. That's a good guess. We do use pi a lot, but not for these. These have square roots in them. Or if it's not a square root, it'll come out to like 0.5 or something like that.
Wouldn't it be square root of 2 over 2?
That one is square root 2 divided by 2. The other way, if you don't know that, is to go back and do unit circle trig. But it's going to take 10 minutes if I have to do unit circle trig 1, 2, 3, 4 times. Okay, so it's a lot easier if you just have them memorized or you can recognize them. Okay, how about cosine of 30? What's 0.866? That's a square root 3 over 2. That's a good guess. How about the sine of 45? If you know the cosine of 45, you should know the sine of 45. Right. These are complementary angles. 45 and 45 add to 90. Sine, cosine. Okay. Sine and cosine are co-functions. If you have complementary angles of co-functions, they're the same thing. Right? So cosine 45, sine 45, same thing. And the last one, sine of 30, comes out to 1/2. Okay. So now we just simplify what we have. It's nice because we have all the same denominator, so if we ever have to add fractions, we already have common denominator. But first, we got to multiply the 2 on the left of the plus sign and then the 2 on the right. What do you get if you multiply the 2 on the left together?
Square root of 2, square root of 3 over 2. Right? Yeah.
What do you get again?
The square root of 2 times square root of 3 over 2.
Hold on one second. Let's go like this. What's the answer to that?
AC over BD.
AC over BD. You multiply these together, right? Okay, so yeah, the bottom here would be a 4, but you said square root of 2 times square root of 3,
It's square root of 6.
which you can combine as square root of 6. Yep. So we get square root of 6 over 4. And then, what about the other one? Square root of 2 over 4. Now, there's not much we can do other than just put one big denominator. And this time you keep the denominator the same because you're adding. Right? So the final answer is square root 6 plus square root 2 over 4. That's the exact answer, and that's as simplified as you can write it for square root 15. Okay, we can easily check it. The cosine of 15 is about 0.9659. And if you type in the square root of 6 plus the square root of 2 and divide by 4, you get 0.9659. Okay. So any questions on that? So some of the problems on the test are just going to be arithmetic. All you have to do is give me the exact value for something like that. Okay, there's no proof or anything. It's just all arithmetic. Okay, this one is a little different. Okay, this one is a verified, which is more of a proof. And it says the cosine of pi over 2 minus theta is exactly the same as the sine of theta. If you remember when we did graphing, sine and cosine were phase shifts of each other. This is kind of proving that idea. All right, so what side do you think I'm going to start with here? What's on the left or what's on the right?
I thought you started with
How about Quinn? What do you think?
left side.
Yeah, we should start with the left side. Always start with the side that looks more complicated and try to simplify it somehow. Does anybody recognize this side? What is that?
Sorry.
It's a difference and it's cosine. It's cosine of a difference. Okay, we have a formula for simplifying that. Okay, so let's take this cosine pi over 2 minus theta. We're not going to do anything to the right. And we're going to simplify that using our formula. Okay, can somebody remind me, what's the pattern for cosine of a difference?
Cosine of the first one.
So cosine of the first, yep.
Then cosine of the second one.
And then cosine of the second.
Plus the sine of the first times sine of the second.
Sine of the first times sine of the second. All right, let's see if we can do these ones without a calculator. Cosine of pi over 2. What's pi over 2 in degrees? 90. So if you draw your unit circle, 90 is right there. What's the formula for the cosine if you know this coordinate? What do you do with that coordinate to get the cosine? It's just the x. Yep. So what would be the x value of that coordinate? 0. We don't know the y value. It could be, well, if it's a unit circle, it's 0, 1. But in general, the x would be 0. So the cosine of 90 is 0. Okay, so we have 0 times cosine theta. Now we can use the same diagram to figure out the sine of 90. Okay. How do you get the sine if you have the coordinate? Andrew, do you remember how to get the sine?
Just the y.
It's the y value of the coordinate. Okay. If this is on the unit circle, what's the y value of that coordinate? 1. All right. So what's going to happen when I simplify? What happens to 0 times cosine theta?
0.
That's 0. Right? This part's gone. 0 plus, what's 1 times sine? It's just sine. And what's 0 plus sine? Sine, which is what we were supposed to get. Okay, so the goal with the verify is, remember, you take the left-hand side, or whatever side is more complicated, and turn it into the other side. Okay, and there is going to be one very similar to that on the test. Okay, so all you have to do is show me this step, okay, that you rewrote it using a sum, or it could be a difference, like it is in this case, and then show me that you know cosine of 90 is 0, and sine of 90 is 1, and then I can see 0 times anything cancels out, and you're just left with 1 times sine. Okay, so that's all you'd have to show. Okay, any questions on that? All right, let's try one more similar to that. So this one says the cosine of pi minus theta equals negative cosine theta. So again, I'm going to start with the side that looks more complicated. And what I just circled, what is that? How would we classify what I just circled? It's a cosine of a difference. Okay, when we're done, we're going to have 6 options: sine, cosine, or tangent of a sum or difference. Okay, this is cosine of a difference. So we'll write it out. Ayla, can you remind me again what the cosine of a difference formula is?
It's cosine
Yeah, sure. Can anyone help her out?
Cosine of the first.
Yep, cosine of the first,
Cosine of the second.
and then cosine of the second. So this one is just cosine, cosine, and then a sine, sine. You just have to remember what goes between them. Is it a minus or a plus?
Plus, plus.
Yeah. Now, when we get into the sine ones, you keep it the same. Like here, we switched it from minus to plus. You don't do that with sine. So it's why it's easier if you make a reference sheet to remember it. So sine of the first, cosine of the second. I'm sorry, cosine of the first, cosine of the second, sine of the first, sine of the second. So sine of the first, sine of the second. And when we say first and second, we just mean whatever's here and whatever's there. Okay, what's after the minus sign. Okay, what's the cosine of pi? Or think of 180. Imagine that on a circle. And I want to know the x value.
1.
That would be for cosine of 0. Would have an x value of 1.
It's 0. Like highest value is 0.
Now, we just said the x value of 90 is 0. It's negative 1. Yeah. Remember, 180 is all the way to the left 1 unit. Okay. So we get negative 1 cosine theta. And how about the sine of 180?
0.
that would be 0. If you draw it out, put a dot on 180, the y value would be 0. Okay, so 0 times sine, that part cancels out. What's negative 1 times cosine?
Negative cosine.
Yeah, which is exactly what we're supposed to get. Okay, so as far as like proofs kind of problems go, these are really very straightforward. You don't really have to think too much about the steps. You do the same thing every time. You fill it into the formula, and usually with these kind of problems, you get 1s, 0s, and negative 1s. Okay. Any question on example 2b? All right, so we've done a lot of stuff with cosine of a difference. I'm not going to do as much stuff with all 6 different versions, but we are going to start looking at some of the other versions. Okay, so we're going to look at the cosine sum. Okay, to do the cosine sum, we have to know these 2 things. Okay, these are things we've done before. Does anybody remember if you take the cosine of negative x, something happens to that negative? Does anybody remember? Like if you took the cosine of negative 20 and the cosine of positive 20, anybody know how those 2 answers would compare? Well, what's one option? If you took those 2 values, I said they could be
The same or different?
yeah, it's one of those. They could be the same or they could be different. So let's just try it and see. Okay. And I just picked negative 20. You could do negative 30. You could do any number you want. So cosine of negative 20 is that number, 0.93969. And I'm going to take the cosine of positive 20. Just try to remember what that one is.
Same thing.
They're the same thing. So the cosine of negative x would be equal to what?
Cosine of x.
Cosine of x. They're the same thing. Okay, we need to know that. And how about this one? Anybody know what the sine of negative x equals?
I think there's no way it's going to be the same like the other.
Any guess what it'll be if you think it's going to be different?
Is it sine of x? That would be sad.
No, if it's negative sine negative x equals sine, oh, you're saying it's equal to sine x? Oh, that'd kind of be like what we did before. That would be the same. Yeah, no, this one does come out different. Yeah, I thought you said something else. No, it does come out different. Let's just pick another number. Let's take the cosine of 30. Okay, 0.866. Oh, I'm sorry, let's do sine. So I picked one that's nice. Sine of 30 is a half. And here's the sine of negative 30.
Negative x.
So what do you think the sine of negative x equals?
Negative sine of x.
Negative sine of x. Okay, so with cosine, if you have a negative in the argument, you can get rid of it. It doesn't make a difference. If you have it with sine, you can't get rid of it, but you can move it in front. Okay, keep those 2 ideas in mind as we figure out the cosine sum formula. So, right now, all I know is the cosine difference formula. Anybody, we're not going to use this idea right away, these 2 things. But anybody have an idea how I can figure out the cosine of a sum formula using what we already have? All we have is cosine of a difference. So we have to use that somehow. So there's got to be what? There's got to be a minus somewhere.
Like instead of the adding both the cosines and both the sines, you should add both the cosines.
You got to have, yeah, you got to put a minus in there. But how could I put a minus in there and still make it equal to what's on the left? It's not an overly, it's just a simple idea from basic arithmetic.
Did you make it negative b and add b?
Yeah, maybe what's after the subtraction of negative so that it's plus.
All right, so can you tell me everything to fill in here?
Alpha, yeah. Minus negative beta.
Yes. Okay, so now
Dan, go ahead.
what we have here is this is a difference. That's your first,
Good job, Milo.
that's your second. Now fill in everything we have there into the cosine difference. Okay, and then you'll have the cosine sum. All right, so Molly, can you tell me, remind me again, what's the cosine difference formula?
Are you kidding? Are you kidding?
Cosine
Yep, cosine
of the first.
of the first.
Stop it.
You don't.
What is it? Say it again. Cosine of the first. Okay, that's good. And then,
Then cosine of the second.
and what's the second in this case?
The beta.
The what?
Beta.
Not beta.
Negative beta.
Negative beta. Yeah.
He's so quiet.
Okay, so cosine of the first, cosine of the second, and then plus or minus?
Plus.
Yep, because we're doing the cosine of a difference. The sign switches to a plus, and then it's going to be sine of the first, sine of the second. So just change the two cosines to sines. Sine of the first, sine of the second. Okay, can I do anything with cosine alpha? No, nothing I can do with that. How about cosine negative beta?
You can put the negative in front of cosine. Or, no, you don't need the negative anymore.
I don't need the negative. Okay, we can just get rid of it. So cosine alpha, cosine beta. And now, before we start writing anything in the second part, we kind of have to look ahead and see what's going to happen. What's going to happen in the second part? Yep.
Well, the negative beta is gonna become, or the sine beta, so it'd be negative sine beta times sine of alpha, so directly turn negative.
Yeah, this negative is going to go in front, so it would be sine of alpha times negative sine beta. So a positive times a negative is a negative. And we can just write sine alpha, sine beta. So what's the difference between the cosine of a sum, the one we just figured out, and the one we had before?
Literally just change the sign.
Yeah, all that happens is we change the sign. And that is your cosine of a sum formula. Okay, so now you've got cosine of a difference, cosine of a sum. These are the two we go the most in depth with. After this one, I just give you the rest, and we might try an example. So what do you think this would allow me to figure out? Yeah? Yep, just sign out. So cosine of a difference. Okay, the first formula, let me figure out cosine, we did what, 15? What other angle do you think I could figure out now? Besides 15 degrees. Yeah, if we did cosine of a sum, pretty much doing exactly what we did before, we can do 75. Now, technically, you can write 75 as a difference. You could do it as 45 minus negative 30. Okay? And then you could do it using the formula we had at the beginning. You don't have to use the sum formula. I think it's easier because there's less to cancel out. But let's, can somebody tell me how to rewrite that whole thing? Let's just start with this. How can you write 75?
60
60 what?
plus 15. Or you could do 45 plus 30.
Yeah, we want to work with angles that are multiples of 30 and 45. It doesn't matter which one you put first. If you're subtracting, it does. Okay. Now, can somebody tell me how to rewrite cosine 45 plus 30? Yeah.
Cosine of 45 times cosine of 30 minus the sine of 45 times the sine of 30.
And every one of those are the exact same numbers we just did in the last problem. So we're going to end up with that square root of 6 again somewhere, and denominator of 4. Okay, we just have to remember what these are. Okay, what's cosine of 45?
Square root 2 over 2.
So that's your root 2 over 2. What's cosine 30?
Square root 3 over 2.
Yeah. Sine 45?
Square root 2 over 2.
And sine of 30? 1/2. Okay, so we can really do all this in one step. What's the denominator going to be?
0. Yeah, 'cause it's 4 minus. Never mind. That's a lot. That's a lot. That's 4.
4, right? You're going to get 4 in the first part, 4 in the second.
Addition. Yeah, never mind. Whatever.
What about the first term in the numerator? Square root of 6. And the second term?
2. Square root 2.
Square root of 2. Okay, this would be hard. So somebody originally had said, why don't we try 60 plus 15? I wouldn't know that answer off the top of my head. These 4, I know, but not the other ones. Okay, how about if I did, let's make up another one, 105. Can anybody give me a way you can write 105? And did you add or subtract?
You can't figure this out.
Yeah. Okay, so if I asked you to do stuff with 105, you could rewrite it like that. Can somebody give me a different way to rewrite 105? I'd like it as a difference. And I only want to use angles that are multiples of 30 and 45.
Yeah, right.
35 minus 30.
Yeah, 135. That's 45 times 3
What's that so hard?
minus 3. So this problem, you could do it as a sum, or you could do it as a difference. In fact, any problem you can do as a sum or difference. So really, out of the 2 formulas I gave you, you only need one of them if you can always figure out that way to do it. Okay? But having the formula for a sum and a difference gives you 2 ways you can do it if you can't figure out one of the 2. And there's more ways than this as well. But any questions on that? Okay, so anything that's a multiple of 15, you should be able to figure out. Let's just make up one more, see if we can figure out a way to do it. Let's do 165. How can I write 165?
135 plus 30.
Yeah, we could just do what we had up above. Basically just change minus to a plus. Okay? And there is a way to do that as a difference. And as a difference, I mean different numbers. 135 minus negative 30. That is a difference, but it's really the same thing we have there. Okay, questions on that idea? All right. All right, so let's see if we can figure out the sine formula. Okay, sine of a sum. Now, this idea right here, we just proved this. This was one of the proofs you did. I think it was example 2a. Sine of theta equals cosine of pi over 2 minus theta. Okay, let me go back for 1 second. Sine of theta
We did.
equals cosine of, okay, we just did that. We're going to use that idea somehow. So the only way we can figure out sine of a sum is if we can rewrite it. We got to rewrite it in terms of cosine, because that's the only formula we know. Can anyone think how I can rewrite what I have there using what's up above? All right, so the first step is you're going to replace whatever you want to convert from sine into cosine. Take the thing you want to convert and subtract it from pi over 2. That'll change sine into cosine. So it's cosine pi over 2, and you got to be careful. Make sure you put it in parentheses, because it's minus whatever you fill in for theta. Okay? And what are we plugging in for theta? Alpha plus beta. Okay. Now, what would I do with that minus sign? Would be my next step. Well, think about it, you've got something on the outside of parentheses. So what do you always do anytime you have something on the outside of parentheses and you have addition or subtraction on the inside? Distribute. Right? We have to distribute that minus sign to alpha and beta. So what would that give me inside parentheses? Negative alpha, negative beta. Now, all we have to do is we have to group this so that one of these, because we basically can turn this into cosine of a difference. Okay? We just have to group it together so it's a difference. So what I'm going to do is rewrite what I have up above. I'm just going to put some parentheses in. Okay, there's the big parenthesis for my cosine function. I'm going to treat the first angle as, let me write it. You know what? I'm going to use like this. This will be pi over 2 minus alpha. That's going to be the first. Minus. And beta is going to be the second. Any questions on what I just did there? So that's the first. That's the second. And now, what do I have right here on this line? Yeah, that's cosine of a difference. So let's use our cosine of a difference formula and figure out what that simplifies to. And that is going to answer the original question, which we had right here. So all we've done so far is rewrite sine of a sum in a different way that we can figure it out. Once we know what sine of a sum figures out to, we don't ever have to figure that out again. Okay, we'll have the formula. Okay, so cosine of a difference. Can someone remind me how that one works again?
Cosine of the first.
So cosine of the first. Okay.
Times cosine of the second.
Cosine second. All right.
Plus
Yep, you switch the sign, it becomes a
the
plus.
sine of the first times sine of the second.
Sine of the first times sine of the second. Okay, so now let's look back up, because these two things, well, one of them we proved. The other one, I think you can probably figure out the pattern. What is the cosine of pi over 2 minus alpha the same as? What's this the same as? Yeah, cosine of pi over 2 minus theta is the same as the sine of theta. So that what I just underlined turns into sine, well, not theta, but alpha. And what comes next? Sine alpha?
Shouldn't that be beta?
Yeah.
Yes, thank you. That would have messed us up a little bit. So sine alpha, cosine beta. Now, what do you think this, I'm not sure we proved this one. What do you think the sine of pi over 2 minus, my alpha looks a little lousy. What do you think the sine of pi over 2 minus alpha is the same as? It's the same as cosine. It's basically this idea. If you take pi over 2 minus your angle, it converts it from sine to cosine, no matter which way you do it. So this is the same as cosine. Okay? We could have proved it, we didn't. Cosine times sine of what? Beta. So here is your formula for sine of a sum. Notice when you have sine of a sum, it's a sum. The addition or subtraction sign stays the same. With cosine, it was the opposite. So that's where it gets a little tricky to try to remember. And what's different about the first two terms compared to like a cosine formula? They're different. Okay? In the cosine formulas, it was cosine, cosine, sine, sine. Now it's not. It's sine, cosine, cosine, sine. So it's similar, but it's a little different. Okay, so this is your sine of a sum. Okay, so that's the third one you want. And what I would do, if you didn't leave room to put them all together, you kind of did the notes in between. Eventually, I would put all the formulas just on one sheet. Put them all together. Sine of a difference, I could go through and do the same way, but looking at this, anyone think they know what's going to change there for a difference? Think about what changed for the cosine formula.
Addition, middle, subtraction.
Yeah, everything stays the same. It's sine, cosine, cosine, sine. But instead of addition, it changes to subtraction. Okay, and with the sine formula, it's always first, second, first, second. That's the pattern. Sine, cosine, cosine, sine. So now, using the sine formulas, you could figure out the same kind of problems we just did with cosine. I could ask you for the sine of 15, the sine of 105, things like that. And all you have to do is make sure that that and that are always multiples of 30 and 45. Okay. So any questions on that? Okay. Anyone need me to go through like a problem like how you would do this? Sine 15? If you were to do it, what would you use for, which formula? Would you use the difference? Or would you use the sum?
Difference.
Yeah, I'd say difference is probably a most intuitive way to write 15. We already did it, 45 minus 30. So alpha would be 45, beta would be 30. And you'd get all the same answers we did before. Okay, that denominator of 4 pops up a lot and stuff like that. Now, what if I asked you to figure this out? You have enough information to do that now. How could you do tangent of 15 based on what you know right now? Yeah, you could do the sine of 15 and divide by the cosine of 15. Okay. Do we know how to find the sine of 15? Yep, and do we know how to do cosine 15? Yeah, so this would work. It's definitely not the fastest way to do it because there is a separate formula for tangent. But the point is you don't need to know tangent. If you ever forget it or you don't have it, you could always do it the long way. Do the sine divided by the cosine, and that's the tangent. Okay, but if If you want to use the shortcut for tangent, you can. Not going to go through the proof of these. We don't use the tangent ones as much. So mainly I'm giving them to you because I gave you everything else. So just to finish off the list, you'll have the last two. And if you look, these are similar. Just the minus changes to a plus and plus changes to a minus. Okay, so tangent of a sum is tangent first plus tangent second over 1 minus tangent first, tangent second. And again, when you work with angles here, make sure alpha and beta are still 30s and 45s. So let's just try tangent 15. We've done the 15 one a lot, so we'll stick with that one. How do we write 15 again? So it's the tangent of 45 minus 30. All right, now let's look up our tangent of a difference and fill it in. So we'd have tangent 45 minus tangent 30 over 1 plus the product of what I just wrote. Tangent 45, tangent 30. Okay, so let's go through and we got to recognize these as decimals involving square roots, possibly. Well, that's easy. The tangent of 45 is 1. Okay, tangent of 30. What is 0.577? It's not a number that comes up with sine and cosine. It only comes up with tangents. It involves roots that what are the two roots that pop up a lot? Square root of 2 and 3. So it does involve one of those somehow, dividing it by something. Anyone have a guess what that one is? Okay, 0.577, that's square root 3 over 3. Okay, if you take the square root of 3 and divide by 3. And now this we already know becomes a 1. Right, we just did it above. And tangent of 30, we just did it above. So 1 plus square root 3 over 3. Now, that's a little bit messy to leave it like that. So what could you multiply everything by here that would get rid of all your fractions? Well, by all your fractions, actually, I just mean the fraction in the top and the fraction in the bottom. Why is there a fraction in the top? What number there is causing it to be a fraction? Okay, so what number with what you just said is causing a fraction to happen?
Like with the tangent?
With the number you just said.
Oh, 3.
The 3, right? If this was a 1, it wouldn't be a fraction.
No.
But because it's a 3, that's why you have a fraction. So what could you multiply everything by to cancel out that denominator? 3. So you have to do it in the top and the bottom, and it's a distributive. So in the top, if you multiply everything by 3, you get that. And in the bottom, you get that.
Don't you want to try to get rid of the square root as well?
That is better than what we had before, but yes, you could still get rid of the square root, but at least you don't have fractions over fractions anymore, so this is a little bit better. But yes, if you multiplied by the conjugate, you could get rid of the square root. I just wanted to at least make sure people could get to that step, okay, distributing out the 3. Okay, so that's how the tangent identities work. All right, so the last Lastly, we're going to split this section into two parts. But the last thing we're going to look at, I think we'll get to, is this. The sine of 2x is not the same as 2 sine x. First of all, one is a horizontal stretch or compression. The other one is a vertical stretch. Okay, so those are not the same thing. Okay, and I think the last one I'll do is example 4. I want to verify that sine 2 theta equals 2 sine cosine. So my hint is I want to start with this. Can anybody think of a way to rewrite 2 theta using a formula we've learned? Think about a calculation you could do where the result would be 2 theta, besides 2 times theta. Something other than that. Yeah?
Theta plus theta.
Yeah, you could write it as sine theta plus theta. Now that's the sine of a sum. So we have a formula for that. It's just that this time the first and the second
They're the same thing.
are the same thing. So everything is going to be the same. And somehow I'm saying it's going to come out to that. Okay, so let's see. Can somebody remind me what's the sine of a sum? Is it sine, cosine, cosine, sine? Yes? So sine, cosine, cosine, sine. What goes in the middle?
Subtract. No, plus.
Plus. We keep it the same. And every argument is going to be what? Theta. It would normally be first, second, but they're all the same. So what's sine times cosine? It's kind of like saying x times y. It's just sine cosine. Okay? And then what's sine times cosine again? So you have a sine cosine plus another sine cosine. You have 2 of them. 2 sine cosine. So what this formula basically does is it's called a double angle formula. It takes having a number in front of the argument and rewrites it in a way so that now the number in front of each argument is just a 1. So we turned a 2 into a 1. Okay? And a lot of times when they ask you to rewrite something, they want to rewrite it so you don't have a number in front of the argument. Okay? That's how you can do it with sine. There's 3 double angle formulas. I'll give you all of them so you have them, but we can talk more about the rest next time. Okay. With cosine 2 theta, there's actually 3 ways to do it. If you just accept you can do it this way, okay, without me going through a proof, you can use this idea to rewrite this 2 other ways. That's a Pythagorean identity. We did that a while ago. People remember that one? Sine squared plus cosine squared equals 1. You can substitute in using this into that. And if you do that, that's one way to rewrite it, just in terms of sine. And another way you can rewrite it is just in terms of cosine. And the last one, kind of like with all of them, we don't use the tangent one as much, but I'm giving it to you just because I gave you the sine and the cosine. And these are all called double angle identities. Okay, so I'm going to put up the homework, and we'll stop with that, and we'll finish this section next time.
At this time, students in buildings 6, 7, and 8 also.
So the homework tonight, just a few questions, not that many to try. It's on 417, 1 to 5, 9 through 11, and 17. Okay, so we'll take a look at that next time. And then next time we'll we'll finish up section 7.5.